Ladies and gentlemen, welcome back to Kerbal Space Program. This is episode 4 of our series in colonizing, or rather, exploring and conquering the Kerbal system and systems beyond. So, in the previous episode, we managed to get to the moon. We got spacecraft orbiting around the moon in the high orbit and low orbit and collected some signs, which we spent in the R&D section over here. We got some good signs, electrics, space exploration, propulsion systems. But today we want to do something even more daring. We want to go to Minmus. But before that, I am actually going to collect a bit more signs, and how I'm going to do that is through a polar orbit spacecraft. So, I've created a new rocket. It's a totally new rocket with, two stages, 8,000 plus meters per second of delta V. So our previous rocket, the Ocampos Mark 1, had maybe around 6,500. So we are getting almost more than 2,000, or rather almost 2,000 meters per second more of delta V. And even the upper stage itself already has 4,700 meters per second of delta V, which is pretty good. And I'm thinking we can use this rocket for the foreseeable future to missions like Duna, to maybe even Dress. We can use this rocket for quite a few missions, and I've called it the Praxis. I honestly don't even know how to pronounce it. Praxis is Mark 1. Yes, I mean, ignore the top, but look at this rocket. The first stage has 6 Arian Drakkar stage fuel tanks. We have the Cyclone fuel tank, as well as a Tor lower liquid fuel tank with the RD-250 rocket engine. This thing is pretty powerful. And then these things are also pretty powerful. So the first stage itself already has 3,400 meters per second of delta V, which I think is possible to bring us to low Kerbin orbit, carrying what is 1.5 thousand tons of spacecraft. Then the second stage is the main workhorse. It's not as doesn't have a high thrust to weight ratio, but it is pretty good and efficient. So it carries 8 Corvus size 1 fuel tanks around the main stage, which is the Centaur B2160 fuel tank with a rocket engine inside that we can't really see, but it is pretty powerful. And then this is the crew capsule that I'm going to bring onto this polar orbit mission. This crew capsule has 2 science labs that we're going to do scientific experiments, such as the V-Splex and the eco-stress. So I tested this already, and I realized what the issue was with the mobile processing labs and why they weren't doing the science experiments, and I figured it out. And we have the science junior as well, because we need to do some science experiments. Yeah. And we have pretty powerful solar panels that I'm going to attach to a custom group. So solar panels, toggle radiators. There we go. So we have the staging set. Let's get the crew on board. We have scientists. Let's have 2 scientists and 2 pilots. Or maybe we'll have 1 engineer. So we have Thomas Evans, Pauline Mercier, Francis Bailey, and Joel Martin on this mission. Look at this rocket. Anyways, let's save and let's launch. So this is going to be a science collecting mission that I'll just leave in the background while we go to Minmus, because one of the experiments takes quite a long time. I think maybe 100 plus days. So we can go to Minmus and back, and then we'll complete the mission for this rocket, this crew mission. to polar orbit. We're going to go to low Kerbin polar orbit. We won't go to high Kerbin orbit, I think, in this time, because I don't have that much resources in terms of food, water, oxygen, and all sorts. But I want to go to low Kerbin orbit, at least. We'll see if we can go to high Kerbin orbit. Anyways, the game is loading. We have a pretty exciting mission. Hopefully in this episode where we go to Minmus. We won't be landing just yet. That will be maybe next episode where we can land on the moon and land on Minmus. Hopefully. Let's see here. Here's a rocket. Let's warp to sunrise. Beautiful sunrise. And we have liftoff. It's very loud. And it's also lagging. There we go. Liftoff of the Pritzitsk Mark 1 carrying the Casterite probe into orbit. It's pretty loud. Let me turn it down. So one thing I've learned about this rocket is we need to do a gravity turn quite late, maybe around 8,000 meters into the atmosphere, because it is not the most stable rocket on Earth. So we'll see how it goes. Anyways, going through the clouds now. Look at this, so beautiful. And I'm going to go northwards, I think, or southwards, we'll see. I don't know which button is which. But we'll start our gravity turn. If we can gravity turn at all. It's barely moving. I'm going to slow the rocket down while we turn. Just going through max Q. I think I need more thrust. The rocket is going to tip over. Okay, we saved it. I think we have about 1,400 meters per second left of delta V. So hopefully that gets us into polar orbit. Let's see. Oops. Made a mistake there. No, I don't want to warp there. Okay, let's go to the maneuver node. It says we need to burn 60 seconds ago, but I don't think that's true. I don't think this stage can get into polar orbit by itself because, I mean, we don't have the assistance of the Earth's gravity or the rotation of the Earth. But that's fine. Let me use some thrust to help it out. Okay. And once we hit 70,000 meters, we will know whether this number is true. Let's see. Okay, our burn is in 45 seconds. I think we will burn at T minus 30. It should be fine. Or T minus... Let's do T minus 35. And burn. The reason why I'm doing a polar orbit here is because I have the MITE experiment on board, which requires a polar orbit. So that's the reason. I think we have to do the last 400 or so meters per second with the second stage. There we go. Second stage activated. Oh, we are stuck on our first stage. Well, that will just explode, that's fine. Nope. Control the spacecraft. Stop going somewhere else. Okay, I think I'll need to find a way to fix that in the future. And in the second stage, we're using liquid hydrogen instead of liquid fuel, which is pretty interesting. We're working with the LR87 engine. We have 4,500 meters per second of delta V left, which is a lot. And we're getting to polar orbit soon. Let me go prograde. Oops. Okay, we're soon reaching polar orbit. I'm gonna cut at when this hits 200,000. Okay. We haven't quite got into orbit. But that's fine because we'll go into periapsis. So, apoapsis here. We can just adjust the polarity or the angle of our orbit. Periapsis at 192. There we go. So, time to maneuver the spacecraft into position, deploy our fairings. Look at that. Oh, well, our spacecraft smashed into the fairing. I think it will. Oops. That's slightly unfortunate. Alright, once we clear the fairings, we will open our solar panels. Look at that. Look at those solar panels. Let me clear all that. So we have quite a bit of nitrogen. We have electric charge that's gaining. Yeah, we have water, we have food. Okay. 10 minutes to our maneuver node. That is 600 meters per second of delta V. Okay, why can't I time warp? Propellant depleted. It's because of you. Uh-huh. Okay. Time warp. I don't know why KSP is a bit laggy today. Look at this. Isn't this beautiful? So let's time warp. And we'll start our burn soon, in 5 seconds. 2, 1. Burn. We are slowly getting there. This looks very brilliant. I mean, this looks amazing. We are currently going to the South Pole of Kerbin. We just came from the South Pole of Kerbin. We're heading to the North Pole now. Looks amazing. So we'll just wait for this burn to finish. We have 350 meters per second left of delta V to burn, which will leave us with just around 3,900 meters per second, 3,800 meters per second of delta V remaining on this stage, which is more than enough to return to Earth. In fact, we could probably even go to Minmus with this stage somehow, but that's for another mission. One thing to know about this engine is it takes time to cut off, so we need to cut off our burn earlier, maybe around 20 meters per second. We'll see. Anyways, our burn is almost completing. Let's cut it off. Oh, that's way too early. Finish the burn. Oh, we don't need to finish it. Okay, there we go. We have ourselves a polar orbit. We can now commit to our science experiments. The sun is right above us. So, first thing I'm gonna do, get the telemetry report and temperature scans are done. But the Science Junior, I believe, is not. So let's start that experiment. There we go. Then most importantly, this V-spec thing takes 180 days. So we should get it started. This eco-stress takes 2 days. Let's get it started. We have a few more experiments on the side. This is a scan set, not that. We have magnetometer report, can't pronounce it. What's this? Oh, this is just a module. And we have a micrometeoroid impact experiment. So it's collecting data. Let's not flag these for transmission. Or you know what? I'll just flag it for transmission. It's fine. Yeah. I think. Oh, I have one more experiment here, don't I? Perform mapping surveillance. Transmit. Okay. Anything else? Think all's good. We're exposed to intense radiation. That's not good. Extreme radiation. How long do we last in extreme radiation? Quite a long time, it seems. Oh, but it's coming down. Oh, it's going back up. That's not good. Oh, it's back down. Okay. Well, this mission is a success. We are in polar orbit around Kerbin. So the next stop. Oh wait, I forgot. Oh my gosh, I almost forgot. The sight and might experiments. That's the whole point of being in a polar orbit. So, okay, this takes a few minutes, but that's fine. Yeah. Look at these solar panels doing their job, giving us almost 30 electric charge per second, which is more than enough. Okay, that's the end of this experiment for now. We've done that in 20 minutes. Pretty good. Pretty good. Now we'll build something very similar to go to Minmus. Let's try that. So, hope everyone's doing great. Everyone's doing fine. This is episode 4 of Kerbal Space Program, which is very exciting. So far we've gone to the moon. We've gone, well, just to the moon and Kerbin. But we're collecting valuable signs, and we're doing pretty well. Okay, let me just rename the cruise ship that I just brought onto the polar orbit. Let me rename that to its crew name. This one, Castorite Crew 1. Except look at that polar orbit. Okay, leave facility. We will now talk about going to Minmus, shall we? I mean, we're gonna do high orbit around Minmus and low orbit around Minmus. Collect as much science as we can. And hope for the best, really. I'm gonna replace one of the lab modules with just more science experiments, really. The service bay, probably. And maybe some mystery goo. Yeah, just to run the experiment through. Yeah. Anyways, the game is loading. Loading. Wait for it to load. Taking a while to load. In fact, there we go. We are back in the VAB. We have our spaceship. So, I don't need you. Let me move this out. I don't need you. Are those our antennas? Or those are the magnetometers? These are our antennas. Oh, I didn't extend my antennas. I'm sure it's fine. I'm sure it can transmit. Actually, I can check, right? Maybe not here. Delete all messages. Okay, we have the Science Junior on top. So what I'm going to do is carry a service bay. And carry a mystery goo, inline mystery goo container. There we go. So we have our antennas, we have our parachutes, solar panels, radiators. We have mystery goo container. We have our service bay, which we're going to open and put in some scientific equipment. What shall we put in? Charged particle data. I think we definitely want that. We want the thermometer. We want the barometer. What else? We want to measure albedo. Ultraviolet photometry, sure. What else can we put in? Micrometeoroid impact data. Let's see, how about this accelerometer? I think that needs to be done when landing. These are all things that we already have. Do we have I don't think we have a magnetometer. But I'll need to put this on the side. Like that. Oh wait, that's blocking. Like that. What else? Huh. Mass spectrum analysis. Why is it rotated like that? There we go. Sorry about that. What else do we need? Electric field data, sure. What else? Perform biological experiments. We can put that in the middle. And put these around. Yeah, I think that's about it. There's a temperature scan. Can we fit the Cosmocat? Oh, we can. I'm thinking we can. Fit the Cosmocat inside. Okay. So we have the magnetometer. We don't need the scan set. This detects micrometeoroids, already have that. So, let me do something. I'm gonna toggle all of these on with a custom group. CosmoCat. Doesn't this have a log data experiment? Yep, log data. Barometer start. You perform biological thingy. Geiger counter start. I have one more inside. Measure. Thermometer start. Whatever this is, start. I already have that done. Collect data. Start. Start. And this one, start. Okay, there we go. Let me do this as well. Start telemetry report. Okay. Then Science Junior, start material study. Mystery Goo, start observation. Okay, there we go. So we have our Minmus. We call this Minmus cruise ship. I'll call this Casterite Crew 2. And I'm gonna need a way to figure this out just now because it didn't work. I'm going to put another decoupler. Let me move this in just a bit. Place this under. So we have two decouplers working, I guess. Yup, at the same time. Then these engines. Okay. Hopefully this works. I'm not sure if it's gonna work. But we'll be sending our spacecraft to Minmus. Shall we do that? I think... Oh wait, I need to set this experiment up. I almost forgot. Configure. Need to do... Let's see if there's a space low and space high. Not this. This is too big. What's this? 120 days now. Let's just do a small one. BTN neutron. Can we do that? Let's try it. We need a high energy experiments lab. If it doesn't work, it doesn't work. It's fine. Gives us 20 signs though. High energy. Where is it? Oh, I need to search. Oh wait, it's here, isn't it? There we go. Just place one here. And place the magnetometer here. Okay. So this is set to BTN neutron. Let's hope that works. Yeah, save for Castorite Crew 2. And then I think we can have a go at the launch to Minmus, shall we? 8,168 meters per second of delta V. Should be enough, I think. Let's go for a launch. What would the next... Oh, the next mission will be landing on the moon and Minmus, isn't it? Yeah. I want to see if... Afterwards, we might want to go to some interplanetary missions, like Duna, maybe. Like, just get a spacecraft to Duna, orbiting around Duna, I think. If we can orbit around Duna, and, I'm not sure. Maybe we can orbit around the sun first, then orbit around Duna. Consider that. Here's our spacecraft. Let me just check. Let me do a quick save first. Let me actually see the map. Castorite Crew 1 is transmitting, so that's good. And it looks like it's doing fine. So let's have a liftoff to Minmus and lag. Great. Lifting off. There we go. We are off to Minmus, everybody. Isn't this exciting? This time we can perform a normal gravity turn. See how that goes. Look at this. So pretty. Look at that cloud over there. We'll wait for about 8,000 meters before starting our gravity turn. Okay, let's start it. Slowly turning. Just make sure not to overdo it. If not, we'll tip over, which would be unfortunate. Okay, slow down the turn. Well, I don't think I did an efficient gravity turn at all. Slow down the turn. Slow down the turn. There we go. Create a maneuver node. And get to orbit. Shall we? Requires 1,600 meters per second of delta V. I think we may need a second stage on that. Yeah. That's fine. Burn time in 5, 4. Get to the maneuver node quickly. 1. I actually don't think my burn time is then, because it's still in the atmosphere. So I don't think that's possible. I think it will reset when we get there. Get to 70,000 meters. Look at this. I still don't know why there's a green square there, but that's fine. Oh, Crasterite grew on this crossing Kerbin's radiation. So crossing 70,000 meters. There we go, we reset to 4 seconds. And burn. Look at it burn. That's the moon right there. We're not going there today though. Okay, let's cut first. Wait for this to go back down to 0. Mm, 10 seconds left. We have maybe 500 meters per second of delta V left in the first stage, so we definitely need a second stage for this. It probably meant I was pretty inefficient with my gravity turn. Burn. Decouple. Burn. There we go, that worked. That worked to a T. Okay. Our first stage is going down back to Earth or Kerbin, and we'll crash and burn. This is not going the most smooth. We are increasing our apoapsis. Our periapsis is slightly increasing. Let's deploy the fairings. Well, one fairing stuck. Great. Okay, we did kind of a burn. We just circularize our orbit here. Or rather, we don't have to circularize, we just need to get it high enough. Okay, let's head to our maneuver node. This fairing is still stuck against us. Please move out of the way. Fairing. Just a 86 meters per second burn. 8 minutes. So let's add an alarm clock. Oh, great. Forgot about you. And we are about to reach our maneuver node. This is exposed to extreme radiation, that's not good. Oh, did I forget to bring crew on this? No, I have Lucy. Oh, I forgot to bring crew on the command pod, but that's fine. We're almost there. Three, two, one. Burn. That's enough. We don't have to do everything. Save some Delta V. Okay, the first thing I wanted to do is to use this rendezvous planner by MacJap, because I'm not very good at rendezvousing with planets. So the first thing I want to do is to align the planes. That is a 237 meter per second burn in 17 minutes. So let's get there. Let's extend our solar panels. Extend our antenna, because the whole point is for them to be used. Extend. Okay, then our burn is in 17 minutes. Let's warp ahead. Almost there. Delete this alarm. Okay, burn. Burn out 200 meters per second worth of Delta V. Almost there. Isn't this exciting? We're going to Minmus, everybody. Yeah, so this spacecraft is pretty good, I think. We're almost there. We just need to burn a bit more. I think this spacecraft is pretty good for its mission. There we go. We've aligned our planes. Intercept with a Hohmann transfer, or whatever it is called. I'm not good. with that kind of stuff. Let me just plan this burn a bit better. Minmus periapsis. Okay. Head to the maneuver node. Burn in 30 minutes. So we can add alarm for 30 minutes. Our burn time is 3 minutes and 8 seconds. That's a long burn. You might want to upgrade this rocket to, you know, stronger second stage engines. Not sure. Might be useful. So far we spent 1 hour in space. It's pretty good. And burn. This will take a while. I can do acceleration while burning. Oh, that's pretty nice. Let's just accelerate. Burn a bit more. There we go. I do not have an encounter with Minmus after that. Let's burn a bit more and see. That was a bit of a fail. I thought I would have a encounter with Minmus after that. There we go. Periapsis. Let's burn a bit more. Where did my periapsis go? Oh, it's hidden under the apoapsis. Burn slightly more. Just ever so slightly more. Okay. We have ourselves an encounter, everybody. We can use this to lower our apoapsis. There we go. 179 meters per second burn in 9 days. 9 days to reach Minmus. Let's add an alarm and warp our way to Minmus. We are leaving Kerbin. There goes Kerbin. Wonder if we can find Minmus or spot Minmus on our way there. I don't think so. There's the moon. Is that Minmus? Nope, that's Blast. Close enough. It's oh no, Francis Bailey has been exposed to extreme radiation. What just happened there? Oh no. Where is the satellite? Oh, the crew mission. Where is the crew mission? Have I lost it? Huh. Casserite crew 1. Exposed to extreme radiation. Can I teleport to this spacecraft? Well, the radiation is going down. How can I teleport to this spacecraft? Where even is the spacecraft? Why is it not showing it to me? Well, too bad on them. We'll check on them later. Anyways, 1 day to this. Hopefully they'll be fine. Oh. Thomas Evans has been exposed to extreme radiation. Hope they don't die. They should be fine. Okay, we are in the sphere of influence of Minmus. How do I go back to my spacecraft? So we can maneuver ourselves. Oh, I need to untime warp. Let's maneuver our spacecraft to the maneuver node. Where is the sun? Where is Minmus? Oh, there's Minmus. Look at Minmus. Look at Minmus, everybody. Right behind it is the Toon solar system. Anyways, 2 hours to it. Let's head our way there. Oh. Pauline Mercier has been exposed to extreme radiation. Well, too bad for her. Anyways, I mean, their mission is secondary, isn't it? This is our primary mission. Too bad. Okay, delete alarm. 50 seconds to the burn. 5. Where's Minmus? There's Kerbin. Ooh, there's Minmus. Burn. Yeah, I think I definitely need to improve the thrust to weight ratio on this second stage. Okay. We have done it. We are orbiting around Minmus, everybody. Look at Minmus over there. Time to start our science experiments by pressing 2. 50 signs for the Cosmocat. Wow, okay. Very nice. Data. Transmit. Inoperable after transmitting. Keep. Record. I don't even have a scientist on board. Oh, brilliant. I forgot to bring a scientist on board. That's fine. Okay, let's just run through these experiments. I think the longest one will probably be the materials bay, or is it maybe one of them in the service bay? Where is the service bay? Here is the service bay. Open. Trying to see inside. We've done that. This takes 5 days, okay. This needs... what does this need? Space low. Okay, that's fine. We'll get to space low soon. I think we just wait 5 days then. Okay, let's skip ahead 5 days. As we orbit around Minmus. There's Minmus. Oh. Our time warp has stopped. Can I disable notifications for you? Notifications. Messages. Okay. This spacecraft. There we go. Oh my gosh, stop pausing my warp. Stop pausing my warp. Stop pausing my warp. I need to Google how to make it stop pausing my warp. Radiation poisoning. Gosh damn it. Who cares about your radiation poisoning? Oh no, Francis Bay. They're all dying. Oh dear. Well, I mean, we can transmit the signs back. We can transmit the signs back. The couples are exchangeable, dispensable. The signs though, that's not dispensable. And we can transmit the signs back. So too bad, I guess. Okay, 3.09 gigabytes takes 4 days to transmit. Let's wait 4 days. Okay. It's been 4 days. Still transferring. Okay, there we go. So it's time to go to low Minmus orbit, which is below 30,000. So I'm going to add a maneuver here. There is enough. Anyways, look at Minmus. Let me take a screenshot of this. I can't really see my spacecraft with Minmus. Print screen. There we go. There's time warp ahead. Okay. And burn. There we go. We've reduced our apoapsis to 22,000 meters. Or periapsis rather. Add a maneuver there. We'll maneuver the spacecraft slowly later. Let's Casserite Crew 1. Let's maneuver the spacecraft. We're going into low Minmus orbit. Look at that. Look at this ice cream planet. A moon. Okay. 9 minutes. Oops, we're getting a bunch of data now from the science experiments. Alright. And time to burn. Why can't I do... Oh, because I'm offline. Well, that's unfortunate. We'll just have to do this. Okay, we've entered low Minmus orbit. Our control node is locked. because we are right behind Minmus, being blocked over here. That's unfortunate. But time to do signs. Press 2, record this, transmit data, transmit, transmit, transmit. Okay, and then we will warp. Warp ahead 5 days. Just spinning around. Okay, let's see. Oh, we're frequently behind Minmus. The planet of Minmus. So what I might want to do is, if we've collected all the signs, we can go into high Minmus orbit. Have we collected all the signs? I think we have. No storage space. Observe and transmit. Record. Okay. I don't even need to transmit the data actually. But I think I've completed all the signs. Is the magnetometer done? Yup, it is. Is this done? Yup, it is. Oh, have you done? Oh, I haven't done EVA report. EVA report. I can do you. I don't think I can do a surface sample, can I? Okay, let's do EVA report. Right above Minmus. 21,000 meters above Minmus. Well, too bad that we killed four astronauts, but that was not the main mission, and I can still collect the signs because they're transmitting signs throughout. So, Lemao, I guess. I'll have to Google how to protect them next time. I think it's shielding. I'm not sure. Anyways, the EVA report is done. Okay, let's go to... Or rather, we can just... exit our way out. Oh my gosh, it's locked under control. It's locked behind Minmus. Okay. Find a way to exit. Oops. What's up, hurry up? Says 216,000. $215. No, I think I went too far. Okay, we will work with that first. 35-second burn. Uh, 15 minutes, let's add an alarm clock. Okay, look at Minmus. Next time we're gonna land a lander on Minmus. Maybe next episode. Okay, close alarm. we are burning. And we are out of Minmus sphere of influence. Okay, there we go. Our periapsis is 220,000 meters. Let's go to our apoapsis and lower it down. What does it say? $226. Oh no, that's not. 32,000. There we go. Maneuver to the node. Coming up in a day. Let's skip ahead. We're leaving the sphere of influence of Minmus. Can unset the target. We've got 20 credits from that. Okay. So a 6 meter per second burn. That's pretty fine. We have 2,744 meters per second left. So we're pretty well to do. We can close this. Close alarm. Just time warp ourselves to the burn. And burn. There we go. Our periapsis is 15,000 meters. I'm sure we'll be fine. Okay, let me do a cheeky quick save. And let's head here. I think that's correct. 9 days, 1 hour. Yep. Okay, let's head there. We're heading back to Kerbin, boys. Where is Kerbin? Ah, there's Kerbin. Let's face retrograde. In preparation for this probably pretty intense re-entry. Sorry I've not been talking much. I mean, there's not much to commentate on, but we are coming back home. Unlike those 4 astronauts that died, well, on our Casserite Crew 1 spaceship. Unfortunate. Okay, let's time warp. Time warp our way down. We're traveling pretty fast. 3,000 meters per second. I think at 100,000 I'll perform a bit of a re-entry burn. Maybe at 80,000, 85,000. Let's slow ourselves down a bit now. This is pretty fast for my liking. Time warp. And the re-entry lag. Come back to me. Yep, there we go. So I'm going to burn until we start seeing re-entry flares, I think. Which is like very soon. Maybe about 2,600 meters per second is when we will stage. Oh, I need to retract my panels. There we go. Stage. Stage, please. There we go. Oh, my magnetometer booms. Stop. Stop. My antenna. Retract. I can't even see the other antenna. Retract. Hello, retract. Are you even retracting? Yes, you are. How's my heat shoot, like, getting hot? That doesn't even make any sense. Well, the rocket is not doing pretty well. But we are doing somewhat fine, I think. Traveling at 2,500 meters per second. Rip that rocket. I think we can slow down in time. It's slightly worrying that we are still traveling pretty fast. Let me close my service base. Can I even close it? Close. Completely forgot to close everything before re-entering. I think we're almost there. We are almost there. There we go. We successfully brought Lucy Driscoll and Edouard Lefebvre back. Not so much the other 4 astronauts, unfortunately. But it is what it is. Let's wait for me to slow down just in time for the parachutes. This is such a huge thing to be landing on Earth, by the way. It's like so tall. Wow, the mountains look great. We're gonna land on the desert. Oh, I forgot to do an EVA high. Ah, that's my bad. Forgot to do an EVA high of Minmus. Oh well. I think we've collected quite a bit of signs this time around, if the game won't stop lagging. If the game won't stop lagging. Hello. Stop hanging. Stop freezing, please. There we go. Look at this. Time to zoom our way down. Reaching 1,500 meters. Our first parachute goes. Slowing us down to 15 meters per second. The rest of our parachutes go. Hopefully slowing us down under 7 meters per second. Yep, there we go, that's nice. 5 meters per second. Yeah. Alright. Oh, is that like a city? Is that a lost city? That's pretty interesting. Okay, we're just making our way down. Oh, we're doing a mass spectrum analysis. Kerbin flying low. Well, we have 5.19 gigabytes of mass spectrum analysis. That's pretty good. Anyways, we have made it back to Kerbin from Minmus. And touchdown. Look at this tower just standing tall in the desert. It's very funny. I believe I did EVA on the desert already. Anyways, it's pretty minimal. So recover. Wow, guys, we did 2 missions today. One pretty successful and one not so successful, I would say. I mean, in terms of science, we did pretty well. In terms of the astronaut surviving, well, that's another question. A bit unfortunate, but it is what it is. Anyways, let's see how much science. Hopefully we get like 300 science. I think we can get 300 science out of this mission. Maybe even 400 science. What do you think? Place your bets. Place your bets. Waiting for it to load. Waiting for it to load. Waiting for it to load. It has loaded. Let's see how much science we got. And show me the screen now. We got 700. We got 740 signs. Oh my gosh, that's a lot of signs. Alright. We got 760 signs now in total. We can use to spend on things. But that will be in the next episode. I'll spend them on... maybe I'll spend some of it now. I definitely want fuel systems because I meant to do that last time, but I actually clicked propulsion systems. Command modules. Yeah, why not? Miniaturization. SAS upgrade. Prograde and retrograde. What else? Advanced constructions. I think I want lifters. I definitely want lifters. Heat management systems. Yeah. Precision engineering. This could be useful. I'll think about it. Anyways, let's take a look at our Casterite crew one. I think everyone on it is dead. Unfortunately. Well, but fortunately for us, we do have an unmanned probe on that spaceship. So, if anything, it's still controllable. I mean, we could bring their dead bodies back to Kerbin if we wanted to. Let's take a look. Wow, this episode is 1.5 hours. But we've done a lot. We went to Minmus, we killed 4 astronauts, and we got 740 signs from everything, which is brilliant. Hopefully next episode we don't kill people. That would be pretty bad. I mean, but the whole goal is science, isn't it? It's not saying that lives are exchangeable, but in this game, in the name of science, well, you never know. Anyways, we're loading in. There we go. As you can see, we have 0 Kerbals here. I think they're all dead. Oh no. Oh, and scientists of level 3 is required to complete this. So we don't even have the full thing. Because, well, they're dead. Oh, that's unfortunate. Anyways. We'll try that one time. We'll try that another time, I guess. What is the science that we've gotten from this? We are transmitting back 6.27 gigabytes of science. And we have 4 slots of material studies. So actually, technically, we could deorbit this spacecraft. Yeah, I'll do that another time, maybe off camera. I mean, just deorbiting this unmanned probe because all scientists are dead. Well, go back to the space center. We'll hire more scientists. It's fine. Yeah. Anyways, guys, thank you so much for watching. I think this will be the end of the episode. We've done a lot today. We've gotten 740 signs. We've gone to Minmus and back, successfully saving 2 astronauts. With not saving, but carrying 2 astronauts in the journey. Unfortunately, we lost 4 astronauts, so rest in peace to them. And their lives will be remembered because they died to radiation. That's pretty unfortunate. But it was completely avoidable and we didn't do anything about it because Minmus was our priority. Anyways, let's hire scientists. Let's hire pilots. Just hire a bunch of them. Leave facility. Hire a bit more. Engineer. Yeah. Okay. Thank you guys for watching. This is episode 4 of Kerbal Space Program. Hope you enjoyed, and I'll see you next time. Bye bye.